Hey, welcome to my video series on geometry. I happen to be using this geometry book here I got from a friend, and I'm going to talk about chapter 8, special right triangles, and I'm focusing on section 1, which is on similar triangles. And one of the first ideas they express is the geometric mean. And if you have a over x equals x over b, then x is considered to be the geometric mean of a and b, and if we solve for x, then that means it would be x squared equals a times b, and so that means x is equal to the square root of ab, and we're going to be using this in the upcoming theorem. This theorem states that if the altitude is drawn to the hypotenuse of a right triangle, so if the altitude is drawn to the hypotenuse, so this altitude is on the hypotenuse here, so we're talking about this right here, then the two triangles form. So here's a smaller triangle and a middle-sized triangle. Then they're similar to the original triangle, the big one, and they're similar to each other. And I'd like to show you something further on this. And what I've done is I've taken this piece here and I'm setting it over here. And I took this piece here, this triangle here, and I set it over here. And what I'm going to do is I'm going to spin this around, so as the hypotenuse of the big triangle is here. The hypotenuse is always opposite the right angle here. So this is with the hypotenuse down, and on this one, if this is the right angle, the hypotenuse is right here. So I'm going to spin this right here like that. And on the other one, if this is the right angle right here still, I'll draw that. Hopefully it'll stay with it. If that's the right angle right there, then this is the hypotenuse. And if I spin this, hopefully it stays. Oops. Hopefully this stays. Nope, it won't stay with it. So I'll just kind of bring that, and I'll erase this little mark that I have here. So I have now all the hypotenuses facing down, right, with our right angle right here, right? And so now we can see what's similar to what. And by the way, if you have two angles that are the same, there's an earlier theorem that states if two angles are the same, then the two triangles are similar, which means that they're the same shape but different size, proportional in size actually. And we can see that we have a right angle here and a right angle there, and angle A. So two angles that are the same. These two, the big one and this little one, are similar, and we have a right angle here and angle B, and a right angle here and angle B. So these two are similar as well. So there you go. So I'd like to show you then what we could do with this with a few examples. So what I'm doing here is I copied this little part of the triangle here, and I'm going to spin it around, and I think I have to flip it. So now what I did is I turned it around and I flipped it. So now I've matched it up. This side's still 4, and that corresponds to the short side of the large triangle, the original triangle. This y corresponds to the hypotenuse of the original. And this side right here corresponds to this. So I can set up a little proportion. And here's that proportion. What I did is I took the 4. Remember, I turned it around and flipped it, so it's 4 over y. So the short leg over the hypotenuse, is equal to, if we go over to this one, the short leg, which is y, over the hypotenuse, which is, it's not 25, it's actually 29. Let me fix that. Now, similar to what I was showing you earlier, what we would do is we would have y squared is equal to 4 times 29. That means that y is going to be the square root of 4 times 29. And we can take the square root of 4. That's 2. But square root of 29, not going to do that. So that's going to be 2 times the square root of 29. So that's y. And to 5x, or to find the value of x, we could use the Pythagorean theorem, where that is, what? That'd be the legs squared, the sum of the legs squared. So x squared plus 4 squared equals y squared. And so that would be x squared plus 16 is equal to y squared, which would be, so that's 2, oopsie, that's 2 times the square root of 29. That needs to be squared. So that is going to be 4 times 29, which is 116. So it's x squared plus 16 equals 116. You would subtract 16 from both sides, and x squared is equal to 100, which means x has to be the square root of 100. So that means x is 10. So x is going to be 10. And then finally, to find z, you can use the Pythagorean theorem. You could use these similar triangles either way you want. I probably would, well, let's practice with the similar triangles. So if I was doing this with similar triangles, I would probably do, maybe I would do x over 25. X over 25. So that means the short leg to the long leg is equal to y over z. And that's the short. So what I'm doing is the short leg here to the long leg is equal to the short leg here, y, over the long leg, z. I mean, there's a variety of ways you can do this, but I'm just picking one. Now, we already know that x is 10. So that means that I should rewrite this as x is going to be 10 over 25 equals, we know that y is 2 times the square root of 29 over z. So we got to get to work here. I might, I'm going to have to move this up a little bit to make sure I got room to solve all this. Let's see. I would probably make 10 over 25, would simplify that to what, 2/5. So this is 2/5 is equal to 2 times the square root of 29 over z. And that makes things a little bit easier. So that means that this would be 2z is equal to 10 times the square root of 29. And if I divide by 2, then z has to be 5 times the square root of 29. So z is then 5 times the square root of 29. And there you go. There's the theorem using similar triangles up and down, and you can just kind of play with it. And the combination of similar triangles and the Pythagorean theorem, you can solve all these kinds where you have x, y, and z all over the place. So that's it. Let me know how you get on with the comments and if you got any further questions. Thanks for watching.